All right, good morning, good evening, good afternoon, and welcome. So today's lesson is part 3 of our final review. It's going to be a very Desmos heavy kind of setup. As you guys can see, I already have the equations pre-printed in here, otherwise it would take me forever to do this review, and that's not the case. It's kind of a low-key day for me. It's Sunday. I wanted to get this video up so that you guys could start studying and continue to study on Monday before we start the final on Tuesday. So let's begin. First and foremost, hopefully you guys can read this. I split up my screen here just because this is how I want you to do when you get to class. Remember how to do this, guys, would be to basically drag a piece like this until it does a little mirror population, and then it would pop up, and then the secondary option would come up. And I can show you that in class as well. But you're going to need this because we need to look at these points here and figure out the answers, okay? So as we move forward, today we're going to focus on a lot of different areas and making sure that you guys can move quickly, efficiently, and rapidly. All right, so let's get going. Which two ordered pairs represent points on this graph? Here's your first graph. It's 9y equals 6x minus 3x. If you can't read this, okay, remember I have notes in class you'll get that you'll be able to read at that time. All right, so my first point is 3, negative 2. Remember how this works, guys, is you would drag on the line to see where it would be. If you have an external mouse, bring it. If you do not have an external mouse, then that's fine. You go slow, and there it is right there. I see it pop up, so I got 3, negative 2 as an answer. So let me make sure I have the appropriate pen set up here. There's 1. The other point would be 3, negative 36. That's a no. 6, 0. If I click over here on this, I get 6 over 0. That's a point. So 6, negative 36 would not be a point. And then the last one would be 9, negative 30. If I go 9 over right here, I'm actually going up. I wouldn't be going down, so I didn't have to check that one. And there we go. Which two ordered pairs represent on this? Okay, so we're going 2 ordered pairs again. It's a steeper line. 2, 6. All right, so I'd go on this. I know this is 2, and I know that would be up to around 6, and let's see if it is, and it is, it just popped up. So there's 1, and then 3, 2. If I go 3 over, 2 up, that's a no. 3, 10, that's a possibility. 3 over, 1, 2, 3, 10 up. And ladies and gentlemen, the answer is yes. Okay, so there are my 2 ordered pairs. Do I have to worry about the rest? No, I don't. You move on. All right, select which each ordered pair that represents a point that lies on each graph below. Okay, so we are now going to do the same thing, but what you're doing is you're finding one point. So once you find an answer, you can just move on. Okay, now there will be multiples. Okay, so let's select each ordered pair. There could be multiples. We'll check that out. You'll see some of these share the same interest, so there won't be, but you never know on this. Okay, so let's make sure and verify that there's only one. So 4 over. So if I go here, 4 over 3 up, that's a definite one right there. 3 over 4 up. So if I go over 3, up 4, nope, that is not 1. Okay, 4 over 2, 4 over 2 up, of course. Oh wait, 4 over 2 up would be right here. That's not 1. Negative 4, 9. Okay, so if I go negative 4 right here at 9, that looks to be a point, and it is. Okay, so negative 4, 9 is a point. And then last but certainly not least, 3, 24. So 3 over 24, no way. So I got 2 more. All right, 7x minus 2y equals 13. Let's check. You want to check these points and make sure. I know it says each, but we found 2 here. Let's go here. So I got negative 5, 0, that's a no. Negative 2, 5, that'd be a no. 1 over right here, and then negative 3 down. And that looks like a point, ladies and gentlemen, and it is. Okay, if I get it on there, I can, right there. And then the other one would be 3 over, 4 up. So I go 1, 2, 3, 4 up, and that's 1 as well. Okay, so we got which ordered pairs? We got right here, these 2 right here, these 2 are not. Hopefully you guys get the drift on this. Look, trace. That's the big key factor as we're going forward. The biggest key for you guys is making sure that you trace a line and you figure it out. But go quickly. Like right here, 9 over, 6 up. No way. Okay, negative 4, negative 5. That looks like a possibility, and it is. Okay, so that's 1. 3 over, 1, 2, 3, negative 1 down. That is a possibility, and it is a point. I can see it jumping. And then negative 6, so it'd be negative 6, 2. That's not even close. So I think we said the answers are, it's not this one, I know it's not this one and this one, so it's the middle two. Okay, make sure you guys get it and you understand what we're doing. Okay, functions are defined by below. At which x value to the graphs f and g intersect? Well, simply enter these in. Now you can put it in f of x and it will fill it out for you, and g of x, and it'll fill it out for you. Remember what you do is you click on the line, you click the point. So what is my x value? My x value in this case is 3. If I were to ask for the y value, I'd put 1, but that's not what they're asking for. Here's the second equation right here. 2x, 17, 2x minus 17 and x minus 10. What do I still have on? Oh, I still have that one on. All right, put these down right here. You click on the line, and you see where it starts to intersect. And when they come together, there's a natural dot. So my actually point is 7. Okay, make sure you guys know that and you see the reality of that. All right, next is a word problem. Now this one here I put on Desmos because I want to make sure you guys understood how this works and the setup involved. Okay, first and foremost, when it comes in relation to this, please make sure you guys understand there are two numbers with the following properties. The second number is, I don't care what the numbers are, but we're going to use x and y. Okay. All right, so the second number is, remember, second number is 6 more than the first. That's a simple equation. Now it says the product of two numbers. Now we've never done this, but remember the product means multiplication. So this would be xy, and it equals what? 6 is, so it says the product of two numbers, we don't care what they are, x and y, is 6 more than their sum. So the sum of the two numbers. There are two equations, okay? They're right here, I'm blocking them. So I could fill it out for you first. So there's one, and then here's the other one. Okay, now, when it's related to this, what'll happen is there gonna be two intersections. There's one here, and there's one there. And what you have to do, guys, is understand that this is a different equation. It's asking for where intersections are. There are actually two, but they give us 2, 8 and negative 6, 0. 2, 8 is not an option, but negative 6, 0 is. So that is the intersection, okay? Understand that, graph it, and use it. You will actually see more equations like this in Algebra 2 and pre-calculus. We really don't deal too many with isotopes like this. We do a little bit at the end of the year, but not as heavy as you will as the years progress. Okay, next on the setup is inequality, okay? Talks about what is the solution of the inequality below. You could solve this for x, okay, where you distribute the 3. So it would be x plus 9 and this, and then it would be 3x minus 15, and you solve for x. However, I ain't got the time for that today in the video, so I just put it in Desmos. And when I do that, I get a nice vertical line, and it's at 12, and that's the only one I have. So there's my answer. Now, if there was another symbol, I would test it and see if 0 is a possibility, and if 0 is a true answer, which that is, this would be the right. It would be x, which in this case would be 0, is less than 12, so that would be right. Same with this inequality here. You need to find this solution, and this is where we'd have to plug in a 0, okay? So here's my inequality. We know it's a dotted line, and it's at 2, and so you have to plug in a value which is a true statement. On this line, we know 0, 0, or 0 in this case because there's no y, it's only x, is a true statement. So you come up here, and we know it's at positive 2, so we get rid of b and d. So we have two options here. And which one of these is a true statement? Is it this one, or is it that one? Ladies and gentlemen, this is not a true statement. 0 is not greater than 2. If it is, we'll have a conversation about how money works. But in reality, 2 is greater than 0, so that is why C is the answer. So you see when we graph these, I'm moving quickly, and you guys will too. All right, place the equations in order based on their y-intercept. The equation with the greatest y-intercept goes on top. Now you could solve these by hand to make sure you get y equals mx plus b, because we know the y-intercept of this is negative 3. If I distribute this, the y-intercept of that is negative 2, and if I multiply that out, 2 times 2 would be negative 4, or you guys could solve it up and put it in decimals. So here's the first one, second, and the third. All right, so now how it works is it says, what is the greatest y-intercept on top? Well, my greatest y-intercept, when I'm looking at this, okay, let me go to the home button, would be blue first, then black, then red. So my blue is the one that sits on top right now, which would be negative. So if I were to rearrange these, it would be negative 2x minus 2. That would be on top. And what's ironic, which I didn't realize this, is they are already in the appropriate order. Negative 2, negative 3, and negative 4. Well, that's good to know in class, so on Monday I'll get a nice little laugh out of that they're already in order. If they weren't in the right order, then of course you guys would have to change it around, but this is actually correct as it sits. All right, place the equations based on the x-intercepts, the greatest on top. Now we know from historically speaking that you can't tell what the x-intercept is. I can only tell what this one is right here. And so my first equation is 3x minus 9. Y equals 2x, and then x plus 3. Ladies and gentlemen, when you plot these out and ask for the greatest x-intercepts and put them x-intercepts on top, you would want to know, can you change this up? Well, once again, what is the greatest x-intercept? All right, you'd want to go positive to negative. So once again, it is actually set up that this would be number 1, this would be number 2, and this would be number 3, so it's already set up for you. And that's going to be hilarious when we see this. Now, what's going to happen is that what you guys are going to understand is on the test, it's not going to do this. All right, there's going to be 3 equations, they're going to be in the wrong order. Hopefully, which I know I did it on this one here, I actually put these in the wrong order. Okay, so let's look at these. Negative 4x, 1.5x, and just x. All right, finally, I have something in the wrong order, okay? Which would be the first one here, or do I? Did I do it the same thing again? Oh, I did. I put them all in the right order. So this, if you guys were to look at these, you'd want to know which one's based on the slopes, okay? Actually, what we're doing is, did I put this in right? 4 minus x. Okay, so what you want to do is put these in matter of slopes. So we know that this slope here is a negative 1, so it's actually not in the right order, okay? So put the equation with the greatest slope on top. Well, we know that this actually slope here is 1, and this slope here is negative 1. So the greatest slope on here is actually the yellow one, or the one in the middle, okay? Or the, what color is that? Well, the red one, all right? So we know that this would be y equals 1.5x plus 2. That's the greatest slope. That'd be y equals x. And then the last one here would be y equals 4 minus x. So at least we do have to rearrange one of these. It's all right. I make the reviews and I'm thinking, oh, this looks great. And then I plot it up here and I'm like, oh, but you guys still get the point, hopefully. All right, this other one right here. Write the value of f of negative 3. Here's your equation. All right, what you guys can do, I'll be quite honest with you, is you could fill this in. And what I mean by that is this would be negative x. Okay, so you'd write negative. And then it would be negative 3 on the inside like this, squared, plus 3, negative 3 minus 11. Then you would solve it out, right? So this would be negative 9. This would be negative 3 squared, which would be 9. But a negative still on the outside, so it would be negative 9. And then you have what? 9, this would be minus 9, minus 11. Okay, you can write that out. Or what you do is you go on the decimals here, and we're going to go out 11, negative 3. If I go down here to negative 3, my answer is going to be at this intersection right here, which would be 29. And if I were to do the math on this, that'd be 18 and 11 is negative 29. Okay, use decimals if you have to. All right, on these ones you will. Given the functions below, select the inequalities that are true. All right, so we're going to turn this off, turn this one on. Now this one here will be relatively simple. All right, you're looking at where the x value, h of x. So h of x means when x is 0. Remember, that's what you're looking at. This is where you look at, so we want to make a note, look at x. All right, that's what you're looking for. All right, when x is 0, what is my number here? It's actually going to be when x is 0, you have a couple of options here. X is 0, it's going to be negative 3. Okay, so this is a correct answer. All right, when x is 1, what is your answer? Should be 0, and that is an answer as well. All right, when x is negative 3, it should be 0. That is an answer. When x is negative 1, it should be negative 4. That is an answer. So we have 4 of them, and the last one is 429. So I go over to 4, and when I'm doing this graph right here, I know I'm hitting 4 right here, and I'm above. So, ladies and gentlemen, the answer is no, because I'm already above 4, and I'm not even at 29 yet. 29 is up here, and it's above 4, so that's the only one that is a negative. Okay, that is a no. Now let's try the other one. I turn this one off, turn this one on, we'll do the same setup. Let me click on these lines and get all these dots. You guys might want to do the same thing, just so you guys understand the setups, and maybe it makes it easier to read, okay? Because when my x value is 0, so once again, when x is 0, it says here that it should be negative 3. The answer should be negative 3, but in fact, it's 3. So this first one is not legit. All right, 1, 8. So if I go over to 1, then am I at 8? If I click up here, I am. That is a true, correct statement. So 1 and 8 is an answer. All right, negative 3, 0. When x is negative 3, is it 0? Yes, it is. Okay, when x is negative 1, so I go over negative 1, it says it should be 1, but in fact it should be what? 0. So that's not a correct statement. And then negative 2, if you go to negative 2, ladies and gentlemen, x is negative 2, y is in fact what? Negative 1. All right, follow along with that. Back the video up if you have to. What you're looking at is for every x value, is the y value a true statement? Negative 3 for x, my y is 0. Negative 2 for x, my y is negative 1. Understand that process and you guys will do great. All right, now we have a couple more here. You guys can see I'm already almost done with Desmos. And so we have here is x plus 3y equals 6. Which graph represents the following equation? Now you could solve this for y if you wanted to, where we would make sure we would subtract x from both sides, then divide by 3 to get your answer, or you can graph it on Desmos, hit the home button, and see which one looks like that. Well, ladies and gentlemen, if I'm looking at this graph here, I would know obviously that the only one that can be is this one right here. All right, same with this one. Graph this function and see what's the difference between the two. You graph it up, you look at the picture, and you tell me which one is right. Now, figure 4 and 1, they look similar, but 4 is above, 1 is below. My line here is what? Above the 0, so that's why it is figure 4. All right, and then we have on here which inequality best represents the graph. Graph the inequalities, okay, and then you figure it out. So, if I got, oh, that's for later. I can do this in my head. I forgot about that. Okay, I can do this one in my head here. So I'm going to skip these two and come back. So let me cover this last one real quick, and then I'm actually done with Desmos because the rest of these are pictures that I can talk you guys through. All right, so if I graph this inequality here, what we had talked about before, if you guys remember, is that here are my lines, but the shaded part that's going to be on here is where the two colors come together. So you have one color, two colors. So you're looking for a graph that has some similarities down, and that would look like the letter A, okay? It's not B because there's no shading up there. It's not C because the shading's on the wrong side, and it's not D because the lines aren't even right. So there's your true answer. And now I'm gonna blow this up and we'll talk about the rest. All right, which inequality best represents this graph? All right, I know by looking at this, guys, that this is gonna be a negative slope. All right, it's 1 down, 1 over, 1 down, 1 over. So I got negative x. You have negative x right here. Then we have on here a minus 1, okay, is your y-intercept. So I'm looking at either, so it can't be, it cannot be A, all right, and it cannot be D because the slope is negative 1. Now you have to ask yourself, look at the dotted line. Okay, now you could put a point in if they were the same thing. This is the dotted line, which means it cannot be this equals to, so I left with 1 point. If this was a statement that just turned like that, where it was the same side, you had to figure out what sign is. Remember what we talked about. Plug a 0 in here and see if it's a true statement or not. Or plug a point in, be like 0, 0. And if it comes out to be true, then understand your reasoning behind it. All right, same thing. We talked about this on the previous guide. Wherever you have a horizontal line, it is always y equals. Okay, so it's not going to be the x's. What kind of line is that? It's solid. It's going to be this one. All right, this would be a dotted line. That's a solid line. All right, we already talked about this. Go back and look if you need to. And here are the final keys. All right, what is the solution of the system of linear equations? You guys, everybody should get this right, please. -2, 2. What is the solution of this linear equation? The system of linear equations here. Here's my origin point. So it'd be 1 over 1, 2, 3 up. 1 over 3 up. The answer is A. And by the way, you will see stuff like this, guys. You know it can't be C or D because the lines cross. What is the solution of the linears here? Here's my point. I'm going -3, -3. Please make sure you guys understand that setup and read the graph. Last but not least, the solution is always the intersection. 2 over, 3 down, 2 over, 3 down. So my point is here. That's it. Study up all 3 days, please. Make sure you guys, if you have any questions that you come see me. Make sure you rest, study, and I know everybody will do well. This final, I expect everybody to blow it away. Even those, the ones that we had talked about, how you struggled in the past. I don't care if you struggle. What I want is your effort on this. And if you give me your effort, I know you will succeed. I know you will pass. And then I will see you guys second semester. In the meantime, have a great day, an awesome winter break, a great Christmas and New Year's, and enjoy your time with friends and family. And I will see you guys soon.